Hello and welcome to Dels Gaming, and welcome to Kerbal Space Program and Dels Astronautical Empire. And here we are at the Kerbin Space Center, and we're going to be looking at a few different items today. First one is going to be, in the last episode I talked briefly about Delta V, the Apoapsis and the Proapsis when we were in flight, but my understandings of them were not great, and therefore I wasn't really correct on a lot of what I said. So I'm going to go through a bit of explanation on some of them in my layman's terms after I've done a little bit of investigation. To do it, we're going to use some examples and get up into space a little bit, and also to do that we're going to take a couple of contracts. So we've got the orbit, which is one of our primaries, to orbit safely and do a circuit around the planet. So that's one, but we'll take on one of these other areas, not a ferrying, but maybe one of the flights here. Let's see, maybe this one, because we used the hammer already. That said, at least we want you to test the R10 hammer solid fuel booster landed at the Kerbin. To perform the test, activate the part through the staging sequence when all test conditions are met. Right, Kerbin landed. Okay, well we can take that one. This one's a simple one because as long as we're using the hammer at takeoff, we're gonna get this by the looks of it. So that's an easy one. Although actually this one, how long has that got to last? Expires in 5 hours. Duration 1 year. I think Kerbin flying altitude 10. So he wants us to activate the Mark 16 parachute at 10 to 20,000 at that speed. That sounds a bit fast. I don't think I really want to do that. To perform the test, activate the part through steering when all tests are complete. Kerbin, so they want a suborbital trajectory for the flea booster. Okay, I'm trying to find. We want to test the escape trajectory out of turbine. Okay. Radial decoupler. Okay, this one is an easy one. We'll take this one just for the moment. Okay, we'll take that one for the moment. Thank you. Right, we'll look at the other ones later. Now, Delta V. A couple of things I want to change on our previous lander. Which one did we use? We're going to have a load up of our Exploder 5. And we'll go through some of these settings. Now, one thing I noticed on the last time we went through is we burnt off the fins on, I think it got too fast for our fins. Now I'm not sure, one of these stages, and I'm not sure which stage it was. At the moment I'm not sure if there's a way to look back on our previous histories. Contracts, engineers report. Yeah, so I'm not sure on that 100% whether that's if there's a way of looking back. Let's just exit out of here for a second and see if we can find it. We had that's the R&D. Administration building, I don't need that. No, I don't think there is. Okay, but basically there was a nice fiery part of our mission which basically got too fast and produced, basically resulted in the fins burning off, so it got too hot for them. We'll give another test on that this time, but we might try and slow that down in a couple of ways. Right, so while we're on the ground, we're going to talk about delta V. Now, there'll be some better explanations on YouTube and other places about this. It is quite complex, so I'm going to simplify it as to my understanding. Now, delta V effectively is the change in velocity required from the standing launch position to wherever it is you wish to go to. So how much you have to change your velocity during the time period from launch to wherever your destination is. That then comes down to all the equations that go into changing velocity. First of all, what stops us changing velocity? Well, we've got gravity, and gravity is a constant and is always being applied depending on the gravitation. But the further away from Earth you are, the less gravity Earth will exert, but something else will exert gravity. So gravity is number one, or not number one, but a first part. Obviously, a big thing in Earth when you're on the surface at the beginning. Drag and wind resistance. As we move this rocket forward, it's going to the wind resistance on all of the parts is going to slow it down. So that's and also when we're coming back in, we're going to have wind resistance on this vehicle. Number three is going to be weight. Trying to change the velocity of this vehicle is going to be dependent upon its weight. So there's a lot of factors, and what have we got to change all of this? Thrust. We use thrust and the thrust to weight ratio, the TWR, wherever it is, the mass and the thrust, to change that. So, and as the ship changes weight, as fuel is burned, etc., that mass changes, so therefore the thrust to weight ratio changes as you go through it. So all these calculations done in parts of a second work out to your overall delta V by the time you get out. So basically, by the time we come to separate section 6 here, we would have caused 1083 meters a second thrust change in velocity, and the next one we stage adds another 1600, and then the final stage adds 3300. Sorry, the final stage adds 1600 to total 3300 meters a second total change. Now, some people have done all these nice calculations for us in advance, and have calculated that basically to get into Earth orbit you need about Kerbin orbit. It's not Earth orbit, it's Kerbin orbit. You need about 4,500 delta V. That will get you into a low orbit type of situation, generally. So that's the figure we are looking for. So what I'm going to do here, we're now creating a new vehicle, which is going to be our suborbital vehicle, or hopefully an orbital vehicle. So what we're going to need to look at is getting a delta V near 4,000. Now this is going to be a first test vehicle to get close to the an orbitary value. Now this is going to be our payload. This 998 meters a second is our orbital vehicle now, and this is what we have to get. So when we're looking at this delta V in the top right hand corner, we have to do up to this stage is where we're looking at. Now we'll make a check. Yep, our parachute is the last stage. Excellent. So we're going to get up to the 998. Right, next we're going to need a fair bit of thrust at this stage, so we're going to put a liquid rocket here, possibly quite large. Now we might have to move this up. It's going to start getting a little bit large now. We're going to go there and put a liquid field, and this is going to be for when the vehicle is fairly much out of atmosphere. Now, how the thrust works. Now, once we're above a certain height, you will find the drag is less, so less air drag. But at the very beginning, the air is very thick. We need a lot of thrust to accelerate the sheer mass we have and get through all of the areas such as wind resistance, etc. Once you are above that, the atmosphere, which is roughly around 40,000 feet, let's say 30,000 feet, we'll find that wind resistance has less effect, and we just need gentle thrust against it. When I say gentle, less thrust is required to keep pushing you and propelling you forward. So we're going to use the liquid fueled at that point. So at the moment, to get into orbit, we've got 1,600. That's our figure at the moment. So we now need another connector. Okay, now we're down at the point where we've got a lot of thrust required to get us to the next level. And what we're going to use is some of the hammer ones that we're doing here. We're going to follow the basic design we've done previously, which is a dual system. I want it actually here because I want it to go this way. Well, see what other options we've got. That's the standard. We've got any other ejectors? No, it's the only ejector we have at this moment. Don't need the service bay, and we don't need the sights at this moment. We might have a look at those later if we get a chance. So, okay, so we've got those rockets there. Now we need to add some more ejectors and make sure they go into the right places. So, there and there. Okay, so now we're going to put some rockets on the bottom. So we're at 2,300. We're ignoring S2 because S2 is our orbital vehicle. From this point, let's just grab it. So if I click there, that point onwards is our in-orbit vehicle. So we effectively ignore that. So we're taking it up to S4. Stage 4 is our vehicle, or yeah, stage 3. You can say to stage 3, stage 4. Once it's ejected that bit, we don't need to see all stages. So we're at 2,300, which is not going to get us that high. Now we'll leave that at 3. Now we're going to add in the big boom thumpers. So we might need to take this up a bit more. I did say this was going to get a big rocket. So now we're at 3,100 at S4. This first booster rocket, because it's got so much weight to carry, you can see the mass. We've got 18 tons we're pushing in this top area, which is quite a lot. And actually, I just realised we might need to put some fins on there. We'll put them just there. There we go. So we don't need some extra boost at this starting point, I reckon. Now we could go for some more thumpers. Let's see how good these thumpers. I've not tried these before, so it could be interesting. So let's just go for, now how is it putting these in? Is it putting them opposite? There we go. Is that level? That looks level. Slightly offset. Might just try and bring them down a little bit so that they are level with there. That looks. No, they need to go up a little bit more, if anything. let's have a look. That looks just about level. So we've got 3,400 to stage 4. So we have not got at the moment enough to get us into orbit. But we're going to do this as a test for a low suborbital test, just to see what needs to be done. Now, what we could do on this as an example is reduce the weight of this. Now, if we were to do this as an example, once we put that back there, see, 2059. Without that last bit, we have actually got less total than we had before, which is interesting. So, okay, we won't be doing that. So we need to put that just there. But this is how you can muck around with the weight to see what you can do. Right, okay, so this is going to be, instead of we're going to call this an imploder 1. And let's give us a go. And if we do get close, we can talk about the Apoapsis and the Proapsis, Apoapsis and Proapsis, which also is arrrghhh and perigee. Is also an equivalent word. Arrrghhh is the point furthest away from the object you started on, so it's the highest point. The perigee is the lowest, the closest point. If you don't see a perigee on the map, it's because you're going to land or crash or not take off anyway. Okay, let's just see. Let's see what go for a launch. Let's see what have we got. Crew. What crew have we got available? We don't want Bill. We need. We'll put Daula into this. We haven't tried Daula. And also there was a bit about the the stabilization system. So we need to have a look. Whoop. The vehicle assembly wheel can't support over 30 parts. Okay, so now we have to go and upgrade this building. So we'll save and then go back and upgrade our assembly. Well, obviously our assembly is has a limited capacity. So if we look that up, bear with me, there we go. So if we right click, so at the moment we have 30 parts. Okay, well let's go back, because that's 225, which is a lot of money. Let's see how big our ship is, and if we can reduce it a little bit, maybe just for this test flight, and get some money. And so how big is our thing? Let's get the engineer report. So we actually have, where's our report? Report. Vehicle. I want to see my vehicle settings. I want to see the vehicle report. No, it's that's not giving me the information I want. Let's have a look here. So no. Okay, I thought I could get a report here somewhere of how big my vehicle is. Ah, here it is, down here. Parts, 33. So if I was to take that off there, you can see it's gone down to 9. On 2 stages, 9 parts. Here we've got 8 and 33 parts. So I either need to get rid of some parts. Okay, so let's see, if we take that out there, and what can we do here? Let's put it back to put that there. So that's 25 parts. There's 25 parts on here, apparently. It's more than expected. The zooming in method here is not great. So, okay, I can reduce the liquid fuel in this section. Have we got any other options for fuel? Don't want to change it for a solid rocket. That's also a possibility. I could also go for this as a possibility. Go for the big but take out the orbital part here. So taking out that stage, it's actually less, not to be suborbital, all stages. Something's wrong here with some of these stages. That should be 5, that's correct, then that. So that's stage 5 is that, stage 4. It's not giving me any fueling for here for some reason. Let's just see what's happening here. That liquid fuel engine, that's Reliant liquid fuel. So that's giving me, for some reason, it's not giving me a delta on that particular part, which is a little bit strange. Okay, let's ignore that. Let's go for, let's delete that part. Go for the Reliant one more time. Reliant. Okay, we've got a delta V now. Put the decoupler in. Okay, and then we'll put this in here. 26 parts. 3,700. It's close. If we were to put one fuel in, put one large fuel. No, we need to put a coupler in there first, don't we? We need to go like, where are we? Our structures. We put a coupler in. We put our fuel in, one fuel, and then we'll put that swiveling engine there. This can be deleted, and then we put another decoupler at the bottom. There we go. Let's see how this all, oops, don't need that one there because we've got one here. Right. Let's see how that goes. How many parts is that? 29 parts. Okay, we're just in the limit. Although, again, it seems to have ignored one of the stages. Stage 3. Ah, okay, I think I'm going to have to put that into that. That's better. It was putting some of the engines in with the couplers, and we need to separate them out. So that seems to be okay. And here also, this needs to be separated. Got that there. This one here needs to go there, and then that separator needs to go down here. Okay, sorting out the stages. So let's just make sure this all works. So bottom stages all fire. Thank you. That gives us 1,000 meters a second. Second stage, they all then get decoupled. Fine. Next, these 3 fire. They then get decoupled with a single decoupler just there. Then this liquid rocket fires, and that's going to be one of our major thrusters at 1,600. That's going to get us to 3,400 delta V. That gets decoupled, and then we have the final liquid rocket booster here, which could either give us the final thrust or is for orbital, suborbital performance. So what we need is a way, if I just take out, let's just do a quick check. I take that out, put this onto here. Is that orbital? See, that would get our pod into orbit in theory, but it'd have no control and we'd have no way of getting him back. So we need to put some sort of controller on him to allow him to get back into space. So let's try putting a different, something smaller in here. So let's put a smaller fuel. We'll get rid of that one. Small fuel, which is the lightest rocket. Yeah, okay, let's just see. That there, 560, that weight is 3,000. Yeah, let's see if we can find a better one. This one here, weight 2.8. Okay, so it's going to have to be that one. Oh, no, I didn't put a coupler in there. Let's put a coupler in there first. Ready for landing. There, there, there. So it's quite heavy, these ruddy rockets. So let's make sure. Okay, we've got a problem there immediately. So that's got to come down here. Thank you. Right. So that coupler's there. Then we got that rocket coupler. I think we've got no stage 3 now, so we get rid of stage 3. That's that rocket there, coupler. That rocket, coupler. Okay, the rest of it all looks okay. Okay, imploder 1. Now this is close, still not quite orbital, but very close. Let's see how far we can get with our apogee, and let's just see if this even flies, shall we? Going to launch. So I'm trying to get the Delta V. So this has all been a matter of looking at the Delta V and getting it as close as possible. Now, one other thing just before I go any further is we talked about the SAS here, and that isn't the secret, Special Air Service. That is the stabilization system. Now, the reason is at the moment, it's only doing a very simple, because we have a pilot involved, he'll just stop it going too mad. If the pilot gets experience and gets a level 1, then we'll get other options over on the left-hand side of the bubble, of the ball, to give us options such as aim for the retrograde or the perigrade, etc. At the moment, we only get this very simple stabilization only, which is fine at this stage. Right, so at the moment you can see our apogee height is 77 meters, which is basically the starting point, I think, of the capsule, and our Proapsis height is actually in the ground, because we'd actually go into the ground at this point, which is not good, not what we're aiming at. So there is no imploder 1. There we go. It's not going to do anything. So if I link on that, there's no sort of movement. As we take off, that will change. So let's just get in here. Now what we want to do is, as we take off, we want to head towards the east a bit here, to start putting us into a semi-orbital type of direction, so that our apogee basically increases, and we're going to try and get our apogee to around about 40,000 feet before we do that. So our primary, we just take off for the first 30,000 meters, then we will turn. Let's see how this goes, and we'll try then to put it onto a slightly easterly direction, so that we can try and get close to it. I don't think we'll get into orbit, but we'll get close. Are we ready, gentlemen? Daula, are you ready for action? 5, 4, 3, 2, 1, go. You see the apogee, perigrade apogee is increasing, so that's where we would want to be going to make sure we get into orbit, ideally, trying to just correct any drift. Our speed is good, our g-forces are not too high, which is good. Right, cutting off, we're at 17,000 feet, 8,000 feet. On these Bahama systems, unfortunately we are drifting off a bit there, trying to bring that back a bit. We're getting a bit fast there, but released at 20,000 feet. Now we want to bring this on slowly, not too quickly, so that we don't lose control. Let's bring this back onto an easterly heading. That's it. Now we're going to give ourselves, try and go for a 10 roughly 10-degree tilt on this here. We'll increase the speed to about 50%. Now our Apoapsis height is now 78,000. So there we go, and to hold that, and I'm going to try and get our target onto the AP, the apogee. Now just before the apogee, we actually reach that point. What I'm going to do is then give it another burn, and now we can see here how our height is. So by giving it a burn at the AP, we will have the biggest effect on our downward area. So we're on the AP. I need to get it as close as I can to there. And then we will give it a burn. So our AP is 81,000 at the moment. If I can get it to, I basically want to increase our, don't want to increase our height, I want to increase just the AP. So the best way to do that is at the highest point of our AP. So I'm going to start putting some burn on now. Now keep it moving towards that AP. Keep it towards that. There we go. 83. You can see our height is increasing. It's the periapsis is the main bit we want to be. You can see that's decreasing or increasing as well. And that's the bit we want to be things. Let's give maximum thrust here. And you can see how the AP, or where it is touching the ground, is getting further and further away. We're not getting higher, we're just, well, not too much higher, we're just increasing the point at where we will land. Now we're almost out of fuel now. So we're going to release that. We're going to have this one available. We're going to give it a 50% burn, but that's it. Let's see what that's done. So I think you can see now we're almost orbital. We're very close to it. So we're going to wait until we get close to the AP. You can see that our height, 119,000, and we're only needed a little bit more burn, and the other end of this line would be continuing on around. So we'd actually see a PE value. So we're going to just speed up time just a little bit so I get closer to the AP point. And I'm going to do another burn again. They use this window to do it. Let's just get online. I'm going to do this manually. A bit twisted. So let's see if I can go like that. There we go. Just makes this a little bit easier for me to steer with. There we go. So it's a bit more natural. Okay, now when I'm just near that AP, I'm going to give another bit of burn. Let's get close and see if I can extend that just a little bit more. I don't think we'll get into orbit, but we'll see how close we can get. Okay, let's give us back into there. Right, let's start giving ourselves a little bit of burn. Whoops, that's too much. Oh, that nearly did it. How much fuel have we got? Right, we've got to be careful here. Our Proapsis is 57 meters, 57,000 meters. Right, we're giving it a very short burn. I want to see if we can get this, see how close we can get this see if we can get the periapsis to almost be, you can see, there we go. The periapsis is almost off the Earth. Now, to be honest, because it's at 3,000 meters, we'll actually not crash, but we'll hit the atmosphere. We would need to get that to almost the same as our current Apoapsis to be able to put it into an orbital, and we'd need to get the PE above 60,000 feet would get us orbital. We might be able to do this actually if we are careful. We're near the Proapsis. Let's see if we can get that up a little bit more. How much fuel have we got? We've got very little fuel. So let's just see how high we can get this. Just give it a little bit more. Right, Proapsis is at 12,000. I need to see what my fuel is. There's one thing we're going to use here, the Proapsis height up on the top left, so I can keep an eye on fuel. Because one thing you don't want to do is use all your fuel up. Oops, let's align myself with the Proapsis, with the apogee, prograde marker, because that is giving us the maximum to our Proapsis. So we'll get in there as quick as I can. If everything's, if my understanding correct, let's give it a little bit more burn. Right, we've got a 70,000 Proapsis height. That may be enough to just orbit. Oh yes, I think we have got it orbital by using our this is a very low orbit. And you can see the orbit, the Proapsis height is actually steadily increasing. The apogee is slightly decreasing, just minorly, but the other one's increasing. Let's see if we can get this orbit. So this was by getting our delta V up high. So that we got enough to get into this area, and then just waiting until you're at the right point of the AP to affect the PE. So let's see, that's our Proapsis is holding at the moment, and so we're slightly elliptical, but I don't want to use any more fuel if I can help it. Okay, while we're at here, we're going to go back to normal. Just think about it. Let's do our tests. We're in orbit. We are in orbit. We're going to have to see if we can get the goo collector. Where's our goo collector? There we are. Mystery goo. 10 science. Okay, we'll recover that, keep that data, and reset. We can still always review the data. Whoop. And we'll get a crew report, which is worth... okay, that wasn't very useful. Right, we have some electricity and monopropellant, so that gives us some ability, but we've got very little liquid fuel. Now that fuel that's left, we've got to use to get our poor little Kerbal back into space. But first of all, let's see if this is going to continue and actually orbit. So we've got a good speed. Yeah, our Proapsis it hasn't shown us as fulfill the contract. Contract complete. What contract? Orbit Kerbin. We have orbited. Excellent. We are in orbit. Oh, that's great. Oh, I love that. That's magnificent. Okay, right. Now we've got to work out how to get back down again. So first of all, let's try and work out where is our base. Where is our spaceport? Because it'd be handy if we landed somewhere near our space area. So let's see, where have we got flags, bases? Right, they're down here somewhere. So maybe they're in the night time. I've forgotten to look at where. Now, is it just here? Is our base? I can't remember. I can't remember. I'm going to have to keep an eye. I've got a feeling it's just here. That's our spot. Okay, so what we've got to do to get that to land back here, or close to that point, assuming it is that point, what we need to do is make our periapsis close to this. Now, because of the way that air will work, we actually have to make it so that it's just above it. Now, at the moment, our periapsis is way over that side. So, what we need to do is get round to our AP again. So we're gonna. Can I warp to here? I don't know if it's going to allow me. I don't think I've got any warp ability. I haven't got enough items to do that. So we're going to get round to here, and then what we're going to do is drop our periapsis a little bit, so that it starts to head towards the planet and starts to degrade. So we're going to give ourselves a degrading orbit. Now the way we do that is at the apogee again. So let's get to it. Let's get close to the apogee first. So we're just coming around. That's our periapsis. And next time I go up, I'm going to actually work out where the hell I'm starting from. Well, I've got a little bit further. Let's go a little further. Come on. There's our periapsis, which is the one we're after. Right, okay, let's go back to normal here. We'll get a little bit closer. There we go. Now, we've got to reduce the PE, and we do it by making modifications at the perigees modified by making changes at the AP and vice versa. So because we want to make the PE go down, we make the change here. Now what we're going to do is aim our ship at the retrograde. So this is our retrograde. Retrograde, i.e. making it go down. Now if we just give, to show what will happen, if we just give a very short burst, you can see the PE is moving. And now I think it's almost going down very slowly. Let's give it another burst. So it's now down to 69,000. Which means, and it's going to be decreasing, but very slowly. Another bit more of a burst. Now, have we got any fuel left? We have no fuel left, which is going to be a problem, because now, okay, now we have no thrust, and this is the problem we had. Okay, well, we don't have to just get rid of that, it's now just dead weight. And we have no reaction thrusters or any other way to force ourselves down at this time, apart from the fact of hoping that when we hit our perigee, we actually hit orbit. Sorry, we hit the atmosphere's surface, and that reduces our height. So let's just get into maximum time warp and see if we're going down at all, because it could be that we're now stuck in orbit.
remember while he EVA, not while he was
oh, we almost went into the debris. That was interesting. Where was that? Over there is our other debris, which are also in orbit with us. We're in a geostationary orbit now. Has our height gone down? Our periapsis seems to be increasing. And sorry, our periapsis is decreasing, so we've got some atmospheric drag, which is bringing us down, which is cool, which means we're not going to lose our poor little Kerbal, but we may have no control as to where he has where he's going to land. But what we're going to do, while we've got the chance, we're going to come down here, because I haven't tried this, is we're going to take our Kerbal EVA. I don't even know if this is going to be possible or if this will kill our Kerbal, to be frankly honest. So let's have a look if we can do this. So, EVA. Astronaut complex upgrade required. Okay, so that means I've gone into this. Oh, I hate when I'm going to this because I'm not sure how I get out of it. Well, this is the inside of our cockpit. Here we are with our Kerbal. Okay. But now I want to go out of here. So how do we do this? How do I get out of IVA? Okay, I will be back in a minute once I've worked out how to get out of this particular mode. So I'm basically now come back. We are slowly descending. But it's going to take quite a few orbits to finally get to a point where we start to hit atmosphere. So I will come back on the video, because this is all we can do at this moment. I'll come back to the video once we are coming into atmosphere. See you soon. Hello and welcome back to our little situation. And it's taken a little while. Every time our brave Daula orbited, it reduced the height a little bit of the perigee and the apogee, and we're now at a point where it's actually just touched Earth, Kerbin. I shouldn't say Earth, it's Kerbin. So if we look at the map now, it was very slow at the first part. Now it's actually basically in atmosphere. We can see that we're actually going to touch down, and actually it's not to be too far away. So the only issue we have at the moment is that our craft, unfortunately, is out of electric. There is no electrics left in it. It's got a monopropellant, which is great, except it has no electrics. Now I am hoping that does not affect the parachute, and the parachute will still deploy, and we're just going to have to find that out. Also, we have no actual control of the craft, because the radial wheels, which are electrically controlled, aren't working, because no electrics. So we now have to just hope. Luckily the heat shield is facing the right way. I think aerodynamically it does that anyway. And once this heat has deployed, and we're in a reasonable speed, we're at 200 meters a second at the moment. I'm going down to just 2 speed. I don't know what that red thing is. That's possibly something I've turned on inadvertently, or it's a few graphical artifacts. It's been running quite a while it's been doing that. Okay, that's good. 13,000. So it's high enough. Let's just try deploying the chute. The chute deployed. Well, that's good. That is good. It means that we have got a chance of Daula actually getting back. It's a bit, possibly a bit far away from our home area. Although I think I will find out where our home area is for next time we come in for a landing to try and work out where it is. Now, whilst I've been doing this long, because it took quite some time, a lot of mission time, so I had to fast forward it, I worked out what I did wrong. I got my icons wrong. Instead of going, I thought I was on the retrograde icon, and I wasn't. I was on the radial icon. So before, and that meant I did not slow up, and it was a lot more difficult than expected, and it should have been. So lesson learned, make sure you're looking at the correct icons on the board here. I can't show them now because we're obviously coming to landing, but basically, yes, it was just totally the wrong icon. I should have been looking at the one I am now, not the radial. They're very similar, but they are different colours, so totally my fault. But we seem to have survived, which is good. We can hopefully get some of this science back. So it was a close thing. We did get into orbit. We have successfully landed, hopefully. Let's see, and we did the stack decoupler, so we should land. We landed as well, so that's an extra one done. Excellent. Now we can recover the vessel back to our area. So yeah, basically, it's attention to detail is required in Kerbal. There's checklists. It's like flying a plane or a spaceship. But when doing microlights, planes, etc., you have a checklist. Things are done in a specific order for a specific reason. So what I have done. What I need to do is just make sure I'm doing things in the right order each time. Okay, so we gained some science. We got a few parts back, but not very much. Obviously, we've got all of the major parts were done, and our crew got a total reputation 155. Should have got advanced to level 1. Now, by advancing to level 1, basically that means we get a little bit more of that stabilization. They're able to do a little bit more on themselves. Okay, right after that near fatality, we will end the episode here, and next time we will have a look what's next on our major list, because we've got some more active ones. I thought that had been done. Test TR-18A stack decoupler. Okay, I obviously have not done something there that needs that to be done. So we'll have a look later on why that was not working. So what have we, apart from fly by the moon, which is could be quite difficult. We may do some of these other items and see what we can come up. So we'll look at some of these next time to see which one we go for. Maybe we'll clue report for hitting up near Bob's Cleft, maybe. Science data from around Kerbin. This could be a good one to do, actually. Transmit or recover scientific data from around here. It's good money, and it's a scientific mission, and we can have another go at that could be good. We don't want to do the ferrying at this moment. So, okay, we might do this science. Yeah, we'll do this science one for next time. So we have two active. One is to test the stack decoupler landed at Kerbin, which I think basically we put a ship out there and test that whilst landed. So we'll see what happens there. And then we need to also test this one here, just to see what that does. Yes. So hopefully that was useful, or you enjoyed that one. We can obviously also increase some of our facilities, which could be interesting. So we can upgrade that to have flight planning. Ooh, which means we could upgrade this one as well. Patch conics visible in map. Okay, we could possibly look at upgrades next time. I think our biggest upgrade is actually going to be the vehicle assembly building, because we need that to support more than 30 parts, which we're mostly going to need to get the science module into space, and hopefully this time we won't lose it. So please click that like button, leave comments below. I know I've done stupid things, but if you want to have a laugh at my stupid things, but until next time, have fun.